All right. Good afternoon.
Good
Guys are ready to go sleep now, right? Lunch, keynote, all that stuff, history of SQL Server, a bunch of sessions, lunch, and here we go. Can you push yourself to the afternoon, right? You got 1:30. How many sessions are left for you today? Like 1:30? 3 sessions left? I think I'm spent. I just did a session, so I don't know how you're going to do that. But hey, welcome to a talk on SQL Server on Linux called What's Next for SQL Server on Linux. I'm Bob Ward, an architect at Microsoft. It's very ironic for me to be talking about this topic. This is my 25th year at the company, aligning with the 25th anniversary of SQL Server on Windows NT. And 7 years prior to joining Microsoft in 1993, I was a Unix programmer. Yes, it was called Unix back then, and doing Oracle C++ development. And so I joined Microsoft in 93. I gave that world up to go into Windows, and I thought there was no chance I would ever be back in that world again. And yet I had the great opportunity about a year ago to start working with the SQL Server on Linux team and working with the product and evangelizing and talking about it. So it's very exciting for me to be here today. And I'm extremely excited to have my colleague Vin Yu with me, who I consider to be one of our deepest experts when it comes to Linux and containers. Vin, why don't you tell a little about yourself?
Hi, everybody. My name is Vin, and I'm a program manager on the SQL Server team. I focus on SQL Server on Linux and SQL Server and containers as well since the beginning when we started this project.
Yeah, Vin and I actually did the same talk at Ignite. We've added a few little wrinkles and some stuff that's a little bit different, a little bit different demo than we did from that conference. You're going to find one of the fun things about Vin is everything's got to be a container for Vin, right? So
everything.
We will do our demos with containers actually today. And he actually pushed me to do one, and I have one as well. So our goal for this session today is for you to learn what we're doing next on SQL Server on Linux when it comes to SQL Server 2019 and even a little bit beyond that. But we might spend a little bit of time looking back. It's been about a year since we launched SQL 17 on Linux and containers. And we want to look back and share a little bit of information for you about what we've learned and just remind you a few things about our architecture and from a feature point of view, what's in SQL Server on Linux. A couple of housekeeping items. This is a huge room, right? There's no way we'll hear questions in the back of this room. So what we're going to do is we're going to go ahead and go through all this material. I think last time, Ben, we had time for questions, and we did this before. So we're pretty confident we'll have time for your questions. So we'll go to the very end, and we'll conclude, and then at that time, you're free to leave or stay and ask us questions. And we will stay here as long as it takes until the next speaker kicks us out, I guess, for questions. So hey, what about SQL Server on Linux? I do get this question. Is anybody using this thing, right? Is anybody downloading it? Is anybody in production? And the answer is yes to all of that. In fact, we do have a few little numbers here. Number one, from a Docker perspective, that's probably out of date even, Vin. It says 6 million plus Docker pools. Is it even more than that now?
We're way above that.
We're way above that. So we can track Docker pools from the Docker Hub. And in fact, Vin is going to talk about a new container registry where we're keeping all our containers now. But we can track from Docker. So that number is probably a little bit out of date. But it does show you the popularity, at least, of using SQL Server on Docker containers. And then we know from our telemetry, even though we won't publish the exact numbers, we do know that from telemetry of people that have turned that on with SQL Server on Linux, there were quite a few number of cores and instances of SQL running in this platform. And then you look to the right-hand side, these are actual published case studies from customers running SQL Server on Linux or in containers that you can just see yourself on the Microsoft website. And I let Vin maybe comment a little bit here, but there's probably a dozen more of big name companies I wish I could put up there that we've talked to that are already running in production or going to, and we just need to convince them to work with them to let us put a case study. I think you yourself have some experience, right, Vin?
Yeah, and in fact, if any of you in the audience are considering this, we would love perhaps to have your company name on the slide as well.
Yeah, exactly. I would love to put your company name up there and showcase the fact that SQL Server, we're very serious about running SQL Server on this platform. We think it provides an excellent production environment for you just as much as it provides on Windows Server. So when you look at these customers to the right, or customers that both Vin and I and others on the team have actually talked to, there's some trends. We kind of got together as a team and said, what are like 3 trends we've actually seen? Like, why are customers deciding to do SQL Server on Linux? Well, number one, they have told us they want to standardize on an operating system within their organization. Now, I'm going to talk a little bit about our opinions, FAQ we've received about should I run SQL on Windows, should I run on Linux? But from a customer perspective, when they approach us or we get a lead to go talk to them about why are you doing this? Why would you run SQL Server on Linux? Number one reason out of the gate is customers, especially that are on Windows, of course, are saying, I want to standardize on an OS, and I'm thinking about Linux being that OS. So therefore, we're really excited the fact that Microsoft has now adopted SQL on this platform. And if you see right here, I say mixed OS and hybrid cloud short term. That's because a lot of these companies have said, I'm not really to make ready that entire switch over to Linux. I still want to run Windows Server in some scenarios, or I actually want to run some things in my private cloud or in the public cloud. And so therefore, I may run some Linux and Windows combined in my environment. That's a very popular thing we've seen. In fact, if you look at Convergent as a customer to the right over there, very interesting story if you go read them. It's literally a true story. They're like, we need to do this mixed environment. We need to move SQL Server on Linux. We don't know how to do it. And I'm not sure Vin, who worked with them, are like, well, just back up and restore. And they're like, what? There's no way it's that easy. And literally, because of the engine architecture, it is as simple as backing up SQL on Windows and restoring SQL on Linux.
Yeah, I'd like to actually add on to that.
Yeah.
And what Bob has written there says mix OS. In fact, what we're also seeing as a second trend, just of recent, it's I want to adopt more than one. I don't want to standardize on one, because what we see is, the databases stick around forever. And in fact, some of you guys might have data that's been sitting around for 15 years or 20 years or even more. But the applications are actually getting modernized at a much more frequent rate. And we see a lot of technology stacks that are built from the ground up on the Linux side. So what ends up happening is you see a lot of applications in your company being built on the Linux. So your application is built there. However, your data is residing on Windows. So we're here to provide choice. So you could imagine this, having SQL on Linux directly translating a choice for developers. Not necessarily running your production workload on Linux. However, as a developer, I want a local environment I can do my dev on.
That's a great pattern, right, Vin? Because you've yourself talked to devs who are like, look, I love the fact now that I can dev and build my app on SQL on Linux because I just want to run everything there. But because of our compatibility, if I still have production on Windows, I can easily still make my app point to that without any changes, right?
Yep.
And look at that second point, reevaluating preferred database. This is an interesting one. So customers are building new applications, of course, right? And if they're in a Linux-type environment, they're thinking, what database platform might I use? Well, up until this time, SQL wasn't even in the cards. So now, because of the fact that SQL's there, we have customers telling us, I am reevaluating now my decision on what might be a standard database platform to use in my apps. And again, because my apps might be running on Linux, might be running in different environments, or be running in SQL on Windows, I can actually point the app to either one with the same type of compatibility. And then you look at this last one. We just have customers saying to us, we would like to move off an existing database platform, whether it's Windows or Linux, and now use SQL, but Linux now gives me a choice I didn't have before. Whether that be the company with the big O letter, whether that even be MySQL or PostgreSQL. PostgreSQL is an interesting one because one of these customers, DV01, is a customer, that huge Postgres shop, loves that technology, their developers love it, but it just absolutely did not scale for the workload. It's a really interesting story. Their company's pretty small, and they're starting to grow, right, with their customer base growing. And they found, as they started growing, that the data need more scale. That makes sense. Their app needs more scale, the database needs more scale. But Postgres did not cut it. And so they wanted to move to SQL Server, but never had that choice. And I think that's one that actually came to us and said, I saw you doing SQL on Linux. I want to work with you guys to do something special. So yeah, it's a good story. So I think Vin's going to like this one. We've actually spoken together several times now on this topic. And one of the things he has implored to me is like, Bob, I want to make sure people understand that, yes, running SQL on Linux requires in some cases, Linux knowledge, but it's the same. So you look at this first comment, is it the same on Windows? So my tongue-in-cheek story, I think somebody's put this on the internet that I did this one time, but I was at an event one time and somebody said, should I run SQL Server on Windows or Linux? And I said, yes. And I was trying to be obviously tongue-in-cheek, but that's just really true. We believe that the product is so compatible that, again, it's more about your operating system of choice. Don't make the database necessarily a choice, but make your operating system choice, and SQL runs well on both platforms. What about performance? Definitely another question we got a lot. Is the performance the same? And our benchmarks kind of prove and have proven publicly that the performance is very similar. We definitely have seen different workloads run a slightly better or worse on Windows or Linux, but for the most part, it's equivalent. And so I'm here to tell you today, do not make your decision of running SQL Server on Windows or Linux based on SQL performance. Make it based on more the performance maybe of your hardware that you're using to combine together with the operating system. Next question is about licensing. And I know this doesn't seem like a technical discussion, but we get this question constantly all the time. Is the licensing the same? So for the most part, if you have an existing license of SQL Server, in fact, sorry, not for the most part, if you have an existing license of SQL Server, you just get it for SQL Server on Linux, either way. I think we still have that special offer. There's like a special subscription offer that's still active right now with Red Hat that if you just want to do SQL on Linux, you need like a monthly subscription together with a discount with Red Hat for that offering. But other than that, the licensing is identical. And in fact, if you've never installed SQL on Linux, it's quite humorous. You'll go through the process of configuring SQL, and you pick your edition of SQL Server. Well, you don't have to put a product key in. We just let you go. We trust you to actually make sure you have a contract with Microsoft paying for SQL on Linux. Somebody laughed, but we do. We trust you. So the next topic, I actually want to get Vin's opinion on this because he spent more time on Linux than I have recently. So do I have to know Linux? My take on that has been you need to know Linux just about as much as you need to know Windows to make a SQL Server run the best on that platform. But Vin, how would you answer that one if I ask you, like, how much Linux do I have to know?
I think if you are just interacting with the SQL Server and that as the engine as itself, that's gonna, a big part of it, you're like 80% there, right? You do need to know a little bit to help, for example, if you're taking a backup, you're gonna need to know how to deal with Linux paths. That's like one of the first things you're gonna
like
notice.
Paths and drives.
Exactly.
And those kind of
things
right?
of that
Networking,
nature. But if you're doing troubleshooting of SQL Server, our DMVs are there.
Right.
So in fact, a lot of your existing processes that just interface with T-SQL will just continue to work as is.
And you're going to see in a discussion about feature parity, that's one of the big things we're going to talk about today is how we've got that together now. But the core engine, like the DMVs that Vin just talked about, extended events, it just works the same. The engine works similar. The one thing that I ran into a little bit that's tough for me is perfmon. Like I'm so used to Windows Performance Monitor as a very standardized tool across all sorts of programs on Windows, including SQL. And for Linux, that's still a space that I'm struggling with a little bit. There's still plenty of opportunity to get operating system information from Linux. But it is true that the perfmon counters are in DMVs. So if you still want to get information for SQL from a perfmon perspective, the DMVs are actually there. What about what Linux are most customers using? So again, no specific numbers, more just our experience. Plenty of customers running Ubuntu. I mean, some of the customers on this list are actually doing that. I would say the predominant, though, distribution for enterprise customers, for us at least, is Red Hat. That's really what customers mostly are talking to us about. Whether it be a customer that Microsoft Field has actually put us in front of, or maybe even Red Hat's put us in front of, or just somebody that we've talked to in the SQL community when they're thinking about making this Linux move in an enterprise mission-critical workload, it has definitely seemed like more like Red Hat, although developers, of course, it seems like Ubuntu is their flavor that they like to use. And then is SQL Server different in a container? I'm also going to let Ben make a comment here, but there are some differences, feature-wise and some functionality. But it is our intention that when you run SQL Server in a container, it's just SQL Server. Quick funny story is that Travis Wright, our colleague, had sent this email out to Travis about Windows containers a little bit and asking him about his opinion. And he literally said to me in the email, "Why do you care?" I'm like, "What do you mean why I care? I mean, I need to answer this question for customers about Windows versus Linux containers." He said, "Look, why don't you think of containers for SQL as a database container? Can you imagine a world where you run SQL Server in a container and you don't care about the operating system that's powering the SQL Server itself?" Think about that vision as you hear us talk today. Think about the talk that I'm doing and Vin are doing tomorrow on containers. That's really what we're actually striving and going after. Ben, what do you think about that comment about what's different in containers?
I tend to agree. I think there's going to be, on the basis of that is SQL will think it's running in whatever that OS that container is, right? Exactly. But for the large part, if you look at the adoption of containers itself, a lot of folks, they're using containers because they don't want to care about the underlying OS. They just care about the application and the main process that's running inside the container.
So again, you're going to find some nuances when you think about the edge of how you configure things to run SQL in containers. But it's our intention that you don't really know. And you don't really care about the OS that's driving the actual SQL Server. So we've actually used this slide many times over the last year to talk about, is SQL Server the same? And again, I have another slide after this talking about the core engine architecture, which we presented before, but I'll remind you about. But this is more about a feature and functionality slide. And it's our intention, except for the third one to the right up there, it's our intention to make sure that when SQL Server 19 is complete, that this table is the same. Now, if you look over to your right over here, you can see in blue the words new. Those represent features that we have announced in SQL 19 that are what I call on the edge of the engine, like replication, distributed transactions, machine learning services, that are now available in SQL Server on Linux just as they are on Windows. Polybase being one that did not make one of our early CTPs, but that is our intention, that same functionality will also be available, even outside the big data cluster technology, on SQL Server on Linux. The one The one part there that is still undetermined is BI services. Now, to be clear, SQL Server integration services, that works on SQL Server on Linux. Even things like SQL Agent already work on Linux. But analysis services, reporting services, even though they can connect to a SQL on Linux from a Windows server, those teams have not really announced their plans. Like, would they ever make that move to run a SQL Server on Linux?
Yeah, actually, I think it's kind of funny that we even have, part of it is even have this session. You see the title here says, what's new in SQL Server on Linux? Next year we won't have a session here at PASS called what's new for SQL Server on Linux. It's just going to be what's new in SQL Server. We're going to get to a point where we're so close to compatibility and features by next year, when we fill out this chart, that there will not be a new, what's new, or a session specific on Linux, unless it's specific around performance or security that involves more of the OS. But the engine itself, we're going to put ourselves out of business, Bob.
I mean, it's funny. I'm not making this up. Literally, we're prepping for this session as we did at Ignite, and we finished the one at Ignite. We're prepping it this time around. And Vin goes, this is the last time we're doing this, right? And I'm like, what do you mean? No, we're going to do this again. It's been fun working with you in this session. He's like, no, we don't need this anymore. We don't need a what's next in Linux. We need just more details about Linux, but also what's next in SQL Server. It is funny you actually mentioned that. That is our goal, put ourselves out of business this talk. So I just want to remind you that if you're wondering, like, how can you make these claims that the engine the same, that column store is the same, that your app compat's the same, that you can back up and restore is the same, many people are not aware of this. And the fact that we have an architecture in SQL Server on Linux where, and I'll just summarize it this way to you that's kind of interesting, SQL Server doesn't know it's really running on Linux, the core engine itself. We have built a technology called Platform Abstraction Layer, which is not emulation. It's actually a very clever set of software that translates things like operating system calls down to the actual Linux layer in a very lightweight, fast performance way, where the SQL Server core engine does not really understand that it's running on a Linux system. The core engine itself. There are pieces of SQL Server for security or networking and so forth that have to understand that, which is why I have something called the host extension layer. But this diagram really in a nutshell is why we can make this claim, that you can take a database and you can back it up and restore it between systems. Or if you've seen clusterless availability groups, read scale availability groups, how the heck are you actually taking an async primary and a sync replica on Linux and going back and forth between these systems? How's that possible? With shipping log blocks. That's because the core engine that drives that technology is identical. In fact, I did a session last year at PASS, a debugging session on Linux. The actual executable of the core engine itself and its DLLs actually run in the process space in a Linux process and don't really know that they're running on a Linux system. It's very quite clever. It's innovative technology based on Drawbridge, a research at Microsoft. And it really is the way that's allowed us to come to market so quickly. It is an interesting set of technology because it does provide capabilities for not just SQL Server, in fact SSIS uses this, and other technologies to run in an abstracted way on an operating system without really knowing the OS that they're running underneath. So with that said, let me just double click a little bit and make sure you understand. Maybe you've seen this before in the keynote, you've seen this before in the roadmap session we did, that just to talk about SQL 19 for a second. And the reason I want to mention this slide is not because I'm going to cover everything on here. And we've talked already about the fact that we're offering you platform of choice. But there's 2 points I want you to get out of this. Number one, on the left, our big data cluster technology, at least today, is powered by 2 important infrastructures. One is Kubernetes and one is containers. So right now, when you go look at how we've been able to achieve putting that huge big data cluster scenario together, it's because it's powered based on Kubernetes and containers. And if I could think of a set of technologies outside of even big data clusters that I know, Vin, for me personally, I've heard more from anybody when I talk about Linux, it's those 2 technologies. It's like, how do I take containers and Kubernetes now and put it in my environment, maybe in my private cloud or even in the public cloud, and start to think about running my infrastructure with SQL Server on those technologies. So when you see some of the rest of the slides today, you're going to see, for example, a very container-heavy type discussion because we think that that is a future that a lot of customers want to use SQL Server, especially when running in a Linux-type environment. And so, this is more to emphasize to you about the fact it's interesting that this slide before always said platform of choice, but look at the bottom point at the end. And this has been, when we were putting this together, saying, Bob, one of the things you might make sure is that is discussed here, this is SQL Server is the platform of choice with compatibility. So, for example, when I've demonstrated SQL on Linux before, one of the first questions I get is that, what about Management Studio? Like, how do I run that thing? I'm like, just point it and it works. If you run Management Studio on Windows, just point it to your SQL Server on Linux, And just about every feature or functionality you have in there runs the same as it does for SQL Server on Windows. So again, this is just emphasizing that it's not, the message to you is not just platform of choice, but platform of choice with compatibility. And so, for example, when you look at SQL 19, some of the new features that we announced, that we've announced already for intelligent query processing, if you think about even just column store and in-memory OLTP technologies, if you think about lightweight query profiling, which we demonstrate in the roadmap session, or data classification, or maybe you heard some cool stuff we announced like TempDB with hackathon tables, system AGs, availability groups with system databases, accelerated data recovery. You just go down the list of these new things we've announced here. All of that works on Linux because all of that stuff exists inside the core engine. So the reason we're making this point to you is that when you start evaluating SQL Server like 19, for example, don't think for yourself, oh, I think I'm going to go down to Linux, but I don't know if that stuff's going to work. All of these things that are a part of the core engine are going to work. And what I'd like to do now is let Vin kind of dive more into, remember I talked about kind of the edge of what SQL Server is about that's not in the core engine and some other topics and what we're doing in the Linux space so that you feel that 19 is going to be a great choice for you from a parity perspective. So Vin, let me take it over.
Right, sounds good. I think I'll just use the laptop here. So this is just an overview slide of just some of the things that we've been working on over the past year. It is not a complete list of every single thing that we're working on. If you look at the very beginning, we had that Windows and Linux comparison slide. Some of these items are the ones that are listed as new. So starting on the very top left, replication and availability groups in Kubernetes. We spent a lot of time on replication. So who here is using replication? It's like most people. So this was actually a blocker for some of our customers to adopt SQL Server Linux. So we took that as a priority here, and we'll have a demo of that shortly in a bit as well. Second is availability groups in Kubernetes. Because of the rapid adoption that we are seeing with our customers of containers and Kubernetes, we needed a solution there around HA. And we spent a lot of time around availability groups Kubernetes, and we'll double click on that shortly in a bit. The next is open LDAP support for third-party AD providers. So what this one is really around supporting third-party AD providers with SQL Server on Linux. So today, if you were to set up AD with SQL Server on Linux, there's a second process that's running. It's called triple SD. And instead of using that second service that's constantly running that provides queries to AD, SQL Server can now take advantage of open LDAP and use this with third-party providers. So your SQL Server could directly make AD calls to your AD provider, your domain controller running on Windows.
You told me before, what are some examples of those providers? Is it Centrify? I can't remember some of the names.
So one of them is Centrify.
Okay.
Right. So there's a list of third-party AD providers if you look at our docs online.
Okay.
There's also Ventela. There's a bunch of other third-party AD providers.
But did you do that because you heard from customers those are like popular environments they wanted to use to configure AD?
There are some of our customers who are using solutions that involve some of our partners who have built a end-to-end solution in there.
Okay.
So SQL Server on Linux will play with those as well.
Okay, cool.
All right. The next is persistent memory, and I'm going to let Bob talk about that later when he talks a little bit about performance, some of the performance enhancements. And the bottom one on the left here is machine learning services with R and Python. So if you are using machine learning services with R and Python and you have a question at the end of the session, we're in luck because Nellie's sitting in the front and you can ask her a question.
Poor Nellie does not realize we were going to put pressure on her. So.
Yeah.
Welcome to the team, Nellie. You just get tagged within the session.
Yeah,
right? So.
and we have distributed transactions, also a really key critical feature. We'll have that in the demo as well. And last but not least, on the bottom right here, Windows Container Registry and the official SQL Server on Red Hat Container image. So I'm going to dive into that shortly in a bit. But this is just an overview slide, right? So the first thing I want to talk about is SQL Server replication on Linux, because this is actually a fairly big subsystem of SQL Server, and hence, if looking at the architecture that Bob was talking about, how we brought SQL on Linux to SQL to Linux, replication didn't fit in that V1 there, so we added it shortly after. But the goal really here is to achieve parity between Windows and Linux. In fact, you could have a topology of replication where you have your subscriber and distributor on Windows and add new subscribers over time. And this could be on Windows or Linux, and this is what we've been having tested in our lab as well. So these are fully tested scenarios. So you could imagine if you want to have a subset of your data, for use on Linux, you can use replication as one of those key mechanisms to bring your data over time, right? And when configuring SQL Server replication, there is no additional package that needs to be installed. This is included in the engine. The only thing that you have to do, because replication depends on agent components, you have to turn agent on. And that's really simple. It only requires 2 commands. One of them is to configure this in your MS SQL Conf, which is the configuration utility for SQL Server on Linux. And the second is to restart your SQL Server so that SQL Server knows of this config. And if this also works with our tooling for replication. So SSMS, if you're using the replication configuration manager, that will continue to work. Replication monitor, all the tools in SSMS that's designed for replication will continue to work when you point at it to a SQL Server running on Linux.
So Vin, would you say it's your intention that you're a customer, like I had a lot of people raise their hands on this, you're a SQL Server replication customer using it today, but you'd like to use Linux as a possibility, maybe even across these machines. Maybe there's some slight little configuration things you have to do, but your intention to this just works, right?
Yeah, so if you're talking about the different replication topologies, whether, like, for example, just the most basic one, snapshot,
right.
Transactional, merge, right. All those other, replication technologies will just continue to work as is.
Exactly.
Right? And, beyond that, setting up cross OS topologies, those are running in our lab. We're testing it
awesome.
Every day as well.
Good to know.
Right. And last but not least, this can be used with Active Directory authentication. So with that, let's just go into a really quick demo of actually showing you how this.
Let me flip over to are you on 4, right, I think?
Yeah.
Okay.
Just start this. Okay, so as Bob was saying earlier, I like doing, one really good reason for using containers really is if you're gonna present to your team anything, I would say not even just outside the realm of even databases, I would say containers are really good because they're just really repeatable. And here I have a demo. I have my demo set up with SQL Server and containers because it just makes it really easy for me to show you. But what I have here, for those who are not familiar with containers, don't worry, I'll bring you along on this journey here. I have this configuration file. It is a Docker Compose file. What that does is it states how I want to run my containers, which containers I want to run, and how they should be started up. So here I have 2 services, 2 components. I have database 1 and I have database 2. What database 1 is going to do is SQL Server is going to start up and it's going to run a SQL file. And this SQL file, some of this T-SQL may be familiar to you, is I'm going to set up the distributor. I'm going to set up the distribution database, and then I'm going to start setting up a publisher. I'm going to add a snapshot publication. This is a very basic demo. I'm not going to go into too much here the details of replication. I'm sure many of you are very familiar with the T-SQL that's behind replication. I'm going to add a publication, add an article to that publication, so I have a very basic table that I want to bring over. And last but not least, I want to start these agents, and I want to start the job. In my second container, what I'm going to do is just create the database. So it's not going to have any data at all, right? Just have a database. And what I'm going to do is do a snapshot from my first container to my second container, and both of these are running on Linux-based OS containers. So going back to my Docker Compose, I have my first SQL Server instance running on port 2500, and the second running on 2600. So with that said, let's just go ahead and start this demo. So all I have to do is Docker Compose up, and what Docker is going to attempt to do at this point is start up both those containers. So Docker Compose up. You can see that if I just stay in the very top here, I'm creating my first database and my second database, and now, because I'm running this in the foreground thread, you can see the first SQL Server instance and the second one start up, and this is the startup, what you see in the error log if you were to have this showing. Right. But now, because I'm configuring so much at once, it's going to take a little while, right? So you can see that I have a database here, right? Starting up the databases. And the first thing that the first DB is going to do is enable replication. So you can see here it's creating some of the tables and functions required to set up replication. It's going to set up the databases, and then it's going to start running the snapshot job. So the first one's going to run a snapshot job, then it's going to start the distribution job shortly in a bit when it's ready. It's running here. Awesome, so that job has started. So if I go to my Azure Data Studio, and for those who are not familiar with Azure Data Studio, or those who are and you've heard too much about it, here it is again. So remember my second database is listening on localhost 2600 on my local machine. So I'm going to log into there. What was the password I said again? So I'm just going to copy and paste. Oops. So I'm going to connect to my instance. I remember at this point, in the very beginning, all I had was in my SQL file was just created the sales database. I didn't have any data entered into it. So if I go here to my sales, I look at number of tables, I could see that the table has been replicated over. And here I could just take a look at it, and we can see that the data was replicated over. And so this demo is available on our GitHub as well under our samples, so I'll share that after the session if you're interested.
Now, how did you do the script again for replication?
That's a very good question.
I mean, you had the whole script to like configure REPL, but how did you do that?
Yeah, actually, I would say I am not a replication guru. If you take a look at all the code here, actually what I did was, if you know in SSMS, there is a script T-SQL button. In fact, that's what I did. First, I set up replication between two instances, and then I put script to T-SQL. And then it just auto-magically generated all this T-SQL script. And then I put in a container, and now it's repeatable.
So effectively, you ran one command and set up a publisher and a subscriber for transactional REPL with just one script, right?
Yes.
Okay, you have to admit, that is a pretty cool way, I have to admit, to demonstrate, test, and set up replication. So, awesome.
Yeah. And now I'm actually going to pass, so that's my demo. I'm going to pass actually back to Bob to talk about the next feature because he built this amazing demo for it.
Hey, thanks, Vin. Using containers, which I was nudged by my colleague to do. So anyways, so great discussion because we want replication, again, to be something you just don't think about. It just works, right? It works very similar to what you do today for SQL Server Windows or across maybe even platforms. So the next area we looked at that we did not get into SQL 17 was distributed transactions. It's interesting. I have a long, storied career working on DTC transactions, even back when I was support to the SQL 7.0 days. So it's funny coming back circle because I remember in those days in SQL 7.0, distributed transactions were a big deal running with SQL because that was one of the first times we really got that type of technology working with SQL. And that includes things like distributed transactions from even what's called OLE transactions. Like you might have an OLE type application and you just want to do a transaction. And you can connect to a SQL server and enlist in a transaction and connect to another SQL server and then run between them. Very common pattern for apps back in those days, and we used to see that all the time. And the SQL Server engine communicates and coordinates with what's called the DTC service within Windows to make all of that happen across machines. And then a more obvious scenario for you is link servers. You might set up two link servers between SQL servers and do like a begin distributed transaction and do an insert across them and everything just works and all is great. The problem is when SQL Server on Linux came out with our platform abstraction layer, we were missing a very important component. The engine itself has functionality built in to do distributed transactions, actually. But that DTC thing is a Windows service called MSDTC, and that doesn't exist on Linux, as it turns out. So we spent a lot of time, Bob Dorr, Kapil Thacker, a lot of the guys in the team spent a lot of time thinking about how should we do this. In fact, they met with the original inventors and the guys who built DTC to talk about what's possible. And so the discussion was like, how do we do this? Do we build our own type of distributed transaction coordinator on Linux? What do we do? Make it open source? And so a lot of discussions about what was possible. And what we landed on was the fact that the PAL abstraction layer provides a very nice mechanism to literally take the MSDTC service and just run it along with SQL Server. So look at this box to the right over here. When I say that represents SQL PAL, what I mean is that's the SQL Server process on Linux. Now, what I didn't show you from that architecture diagram before was the SQL agent process and SQL Server processes you know on Windows both run in the same Linux process today. Okay, people are looking like, what? How do you do that, right? Well, it's actually possible to do that. The way you actually load these processes up, they actually can run in the same process space in a very clever way. So we said, why don't we just do that with DTC? But there's a problem with that in the sense that DTC has some protocols that you must adhere to for an application point of view. So look at this diagram. An MSDTC client in this case could be another SQL server, that has to participate in a distributed transaction. And so MSDTC that's running in the PAL itself and SQL Server has some unique characteristics. Number one, there's a known port number that DTC works with that's kind of fixed, and it's port 135. And so what we had to do is build something called an endpoint mapper in SQL Server to accept a request from 135. Well, what is that request? That request is actually to go back and tell SQL Server that's the port you should use to communicate now between the two DTC services on different machines. So that was kind of a challenge to go figure all that kind of type things out, but we built all that technology inside the PAL itself. And now that gives us effectively MSDTC-like capabilities on Linux between two distributed transactions, between two SQL servers. It even allows us to support native XA transactions, which we weren't quite sure that we would actually do that as part of it, but we do actually support that now as part of these changes. And then we had to actually make some engine changes to support things like JDBC and ODBC for transaction support, because they actually relied on some extended stored procedures that we kind of realized as we dug into this. And so we had to make some specific engine changes to support those drivers. And then the ODBC driver itself had to be changed for Linux to support XA. So let me show you a demonstration of this. And it's so funny. I was building this demo, and I was talking to Vin. He's like, Bob, use containers. I'm like, I don't know, Vin. I have started playing with containers, but I don't know about building like multiple containers, have them talk to each other. He's like, no, you can do this, right? So I spent some time working on it. I spent some time with our DTC team to make this work, and here's what I landed on. Let me step back for a second, though, and show you something before I showed you this. So I've seen Vin do Docker Compose before, and I've tried it myself with some apps, and I kind of understand how it works, but I wasn't totally sure. So I said, let me start before that. And so what you see in front of you is two shell scripts to run two containers. Let me zoom in on this a little bit. So the idea here first is to run a Docker run. Now, you may have seen before from Vin and others that when you do a Docker run for SQL Server, you've got to provide some environment variables, things like SA password and like a EULA agreement. Well, here's some new ones that you need. Let me go back over here and move it back. Okay, there they are right there. So the two new variables you need are what's called MS-SQL RPC port, which is that endpoint mapper, right, 135, and MS-SQL DTC TCP port. That's the actual port that the true DTC service is going to listen inside SQL Server. So with SQL Server outside of containers, you have a specific way to configure that with something called MS-SQL Conf, okay? But you don't use MS-SQL Conf normally for containers. That's what is different about using a container technology from a configuration point of view. We have equivalent environment variables from MS-SQL Conf parameters to use for containers, which is why you have EULA, SA password, et cetera. So what we've done is just extended the environment variable set from what's in MS-SQL Conf to include these two port parameters. So that's really cool and interesting. And so I added that. That's per the documentation. You have to do a couple of other interesting things, though, when you run these Docker containers without doing Docker Compose. Number one, here's what I'm doing. I'm actually mapping the port for SQL Server here to 1401. That's kind of like normal. We do that when we normally run a container. But I also have to map, let me zoom in here if that's going to work. I also have to map the other two ports, the ports themselves for the RPC, for the endpoint mapper, and the actual TCP port. So I have to do several port mappings here. And I ran all this, and I got it going, but it didn't work. Like, it wouldn't talk to each other. I did a begin distributed transaction, and things just fell apart. And so I'm talking to the team, talking to Vin, trying to put this back together. And what it dawned on me is the problem. The problem is that when two containers start on the same machine, by default, they can't necessarily talk directly to each other unless you've got specific types of networking set up. So here's the problem. IP connectivity works between containers, but host name resolution doesn't. So I was trying to use a server name, right? I would call a SQL, I would like do SP add server for DTC1, and I would do it inside T-SQL, but then SQL Server couldn't talk to that by name. So that was the issue. And so in Docker, you can set up what's called your own network, like a user-defined network. And when you do a user-defined network, and you have a way of actually telling your containers, like here, you can see the network parameter here called isolated NW. There's a Docker command to create a network, basically. It's called a bridge network. You actually tell your container, I'm part of that same network. You literally have built a little VNet between your containers. Now, all of a sudden, everything worked. I could say, this server name called DTC2 and DTC1 can actually talk to each other. So that's really interesting, and that took me several hours to figure that out. And then I'm like, but Vin doesn't do this. Like, why doesn't he do this? So when I asked him about Docker Compose, we were actually chatting about this. In fact, I was chatting the other day. I'm like, Vin, what's the magic of Docker Compose? And the magic is that when I set these up with host names and these names, DTC1 and 2, automatically when I run my Docker Compose up, it will build, actually, sorry, is it added to the bridge network or build its own network?
It'll build its own.
It builds its own user-defined network automatically for me. I'm like, no wonder this guy does this all the time. So by using Docker Compose, just like he did in replication, my DTC1 and DTC2 names become the server names, actually. And in fact, if you go look at like Etsy hosts inside these containers, there's an IP address for each one inside the containers themselves. So because of those names looking like this, I can then go do an SP add server. You'll notice in here the other parameters like Vin had for his just password and EULA. I've added agent enabled because I want to make sure that the SQL server is starting. I think you had to do that as well, right, for REPL. And then I have RPC port and DTC port. I don't think I even need agent enabled for the DTC case, but I put that in there anyways. But also notice I've got port mappings. These are the same thing as those -p commands that I was running earlier. So once I do this, let me also show you how this works here. I think I've got the, let's see, LS. Oh, sorry. So now I've got the Docker Compose, just like Vin did. What do my container definitions look like? So, you know, why build your own thing when you can just reuse? You notice the pattern here that Vin had, which is a Docker file, an entry point script, a DB init script, and a DB init SQL script. So I just took literally his own Docker example, which, by the way, Vin, you've put that on SQL Server samples, right?
Yep.
Yeah, so if you go to GitHub for Microsoft, we have a set of SQL Server sample directories, including wide world importers, and Vin has put a directory up there called containers. And then there is this replication example, and so I'm going to go put DTC after the event. So if you go look at entry point, it looks the same. The difference is this one, is dbinit.sql. So just like Vin had scripts in there to create replication, notice mine. Mine is to do an add link server for a name called DTC2 because that's the remote server I want to do distributed transaction with. I just called it a SQL server. I actually just create a database on that side called DTC Linux 1. This is my local server now, right? And then on the other side, I'm going to create a database called DTC Linux 2 and a table called DTC table. So all I'm doing instead of the replication scripts is adding a link server and creating a database that I'll do distributed transactions with. So let's go run this bad boy. Sudo docker compose up. And just like how Vin's, the actual container cells are getting created, the image is already pulled down, so they don't have to pull those down in this particular case. And now it's going to start running SQL Server. Now, I don't remember if you just said this, Vin, but when I first see this output, I get like blinded, like what is going on here? When you learn about our talks tomorrow, we're going to dive more into how containers work. SQL Server, literally how containers work in this scenario, run from the command line. It's not a service running at that point. So when you run SQL from the command line, you ever done that before? What happens? It just dumps the error log out on the screen, and that's what's happening here. You have two SQL servers all running, trying to each dump out the error logs between them across your screen. So one thing you can do in this particular case is hit Control-Z when I've run this here, and now these containers are still up and running. So if I do a sudo docker ps, the two containers are now running SQL servers together. So how would I do distributed transaction? So if I go back a directory and look at a file called DTC insert.sql, here's what I'm doing. Because you're using distributed transactions, you must do a set exact abort on. That's just standard in SQL on Windows today. I do a begin distributed transaction. Here, I'll zoom that a little bit for you guys. I do a begin distributed transaction. I use my local database on DTC1, that server. Notice I do an insert into the local table, and then I do insert, and notice here's the link server syntax, right, into the remote table, and then I commit. And because, again, that DTC2 is recognized in this user-defined network, I can just specify this name without any of the configuration. So cross the fingers and hope the demo works. Okay. Oh, need a name there. -s localhost 1401. Okay, let me put my password in. maybe. Okay, now it's actually connected to the local server, making the distributed transaction across to the other server. And you'll see it just finishes. Now, how did I know, like, Bob, did you fool us? Did you actually put some sort of fake thing that it really didn't actually do that? Well, let me show you something here. Let me go run a bash interactive shell with my container. So I'm going to interact with my container from a bash shell perspective. And I can run commands as though I was in the container. Let me get that. I never remember that syntax, Vin, so I think I've got it here somewhere. There we go, right there. See this command right here? Here is a sudo docker command saying exec interactively with that container called DTC1 where I started the transaction, run the bash shell. Now, why am I going to do that? Well, there's several ways to go look at the error log, but I'm just going to go in the container and dump it out myself. So if you go to var opt msql log, oh my gosh, there's the Windows experience kicking in, right? Type. You guys see this at the bottom here? Here we go. So we have initialized the DTC transaction coordinator inside SQL Server, demonstrating we're doing DTC transaction in the service itself. You have a question?
In Windows DTC, you can see how many distributed transactions are in flight, have been aborted.
Yes. Yeah, the question is that how do you see all that DTC stuff? We're still working on that. We don't have any GUI for DTC necessarily, so trying to get DTC log information, those kind of type things, I think the team is still working on those kind of things. So let me finish, and I think as we said before, I'd like to take questions at the very end versus in the middle, but thank you for asking them. Okay, so that's the basics of it. That is really, really what we put together. If you want to start doing linked server transactions now, or distributed transactions across linked servers, you could not do that before. In fact, if you tried it with SQL 17, you would just get an error. Now, whether you do it in containers or if you do it across VMs or across bare metal, you have all those capabilities. And you notice I just used the standard T-SQL language to set up my link server. It wasn't a separate set of configurations. The difference is configuring the ports for DTC, which we document, how to do with a container or how to do with a server. So, Vin, I hope you're proud. I hope I made you proud by doing a container demo. So.
I am.
Awesome. Okay. So let me continue on by talking a few other topics here, and then I'm going to let Vin conclude us by talking more about containers and where we're headed in that direction. I don't know if you caught me I've been in a couple of videos here at this conference in the keynote, but in the very first video that Rohan had, they interviewed me in Texas, and they asked me, what is it like, 25 years in this product? And if you think in those days, 25 years ago for me, it was all about just an engine, right? It was an engine. What did he say? I built a clustered index, right? It's T-SQL selects, it's DB library, it's Visual Basic. This was just a relational set of tables for us to power transactions with. And so if you heard me in the video, the comment I made was, we have tried to really transform ourselves from a database engine to an engine that's part of a platform. And what better way to talk about the fact that we have a platform than our extensibility? I'm going to talk about that in a second. Let me first mention to you a couple of technologies that we've worked on from a performance perspective. So persistent memory optimization is a feature that we shipped in SQL Server 2019 CTP 2.0, and it is Linux only right now. And the whole concept is that we use this term enlightenment. And the idea is that if we can detect that your database itself, the database files, are sitting on a persistent memory device, we will be able to use APIs in Linux to bypass the I/O stack and just copy memory back and forth between this device. Try to improve your I/O performance on those type of devices. So that's one feature that shipped in 2.0. The second feature is a little more complicated. I don't know if Argenis has already, he did it in a pre-com. I don't know if he's already talked about this so far in one of his sessions. But the new feature in 2.1 is called hybrid buffer pool. And that is actually orthogonal to Linux. That's available both on Windows and Linux. And the concept is that a little bit like buffer pool extension, but different, we will be able to extend the buffer pool in a new and interesting way on top of a persistent memory device. Instead of just putting a database file out there, we'll just recognize it, and we'll start integrating it in to buffer pool operations. So those are two performance enhancements we made. One thing that Vin had earlier on his slide that I didn't have here is something called memory notifications. So I've talked at many different past conferences about memory before. And one of the things SQL Server prides itself on is being able to recognize memory pressure. And so it turns out in SQL 17, before SQL 19.2.0 came out, we did have a few issues on Linux where we didn't properly recognize external pressure coming in from external programs on Linux, and that's been now changed and cleaned up in SQL 19. One of the questions you may be asking yourself at this point, as we've talked about some of these features, is that, are you guys going to backport this stuff? Is this stuff going to go back to SQL 17? And that's still a conversation we're having. I think it's our intention that we'd like to do that. It's just a matter of how long it would take and then what resources we put onto the table and when we would do it. But I think it's our intention as a team that we'd like to be able to do that. Okay, it's funny that, it's ironic that Nellie's sitting here in the front row. You maybe saw Nellie in the keynote. And so it's funny, but when I was thinking about speaking at Ignite on SQL Server 17 or 19 overall, I was meeting with Nellie, and I'm like, Nellie, I heard you work on this Java stuff. Java excites me, And at that time, if you think about what we've talked about in extending T-SQL, it's all about the term machine learning services. And there's no doubt that R, Python, and even Java can be used in those type of scenarios. But when Nellie and I are talking, I told her, I said, look, from a SQL community perspective, having Java changes the game because Java is perceived as more of a general purpose programming language. And if you're out there thinking that the T-SQL language doesn't provide the functionality you need, maybe you can extend it yourself by using Java. And so we made this decision that we would use the same architecture, very similar architecture we've used on SQL Server 16 and 17, where we run R and Python to run Java programs, Java classes. And so Nellie demonstrated that. I showed it in the roadmap session yesterday, and I'll show you an example here in a second. We use this stored procedure called SP execute external script, where you can run a Java class. You'll actually take a parameter of passing in a SQL query, and you can interact with that data and return a result set. And so I want to make sure you understand something about the architecture first, though, because it's very important. Because when I mention the word Java, people are like, what are you doing? And if you've not seen our architecture program with R and Python, the concept is that we will run your program or your script not in the SQL Server process space, okay? Even on Linux, where we have the PAL, not in the process space, but on the same computer to achieve performance. And we will integrate even technologies like Resource Governor so you can control the resources that go against these scripts or programs. And we use a process called Launchpad, satellite, that kind of terminology, both on Windows and now with 19 on Linux, we've made that technology available to run as a separate process on Linux to control the execution of these programs. Now here's the great story. If you're an R or Python program, as you know, they're very compatible, right? Running across operating systems. Well, so is Java. So let me flip over to this screen for a second and just show you what is possible. I demonstrated in the roadmap session yesterday. Let me move over to this machine right here. I demonstrated in the roadmap session here. Let me get this screen up. A program that looks like this. And Nellie gave me this example here called an n-gram, which is a word classification type algorithm. And so there's no n-gram function in T-SQL, so how would you do that with SQL Server? Well, you could actually go out there and write a set of Java classes that perform this, and then you could do something like this. You could actually use this SP execute external script, put your Java classes in a known directory. Notice I'm using the Linux path here, right? And then you would run here your Java class itself, and here's a query to pass with it. Now here's the interesting part of this demo. So in Windows, I built these Java classes on Windows with Java runtime, with Java SDK, I think it was 1.8. And so I was talking to Nellie going like, how do I do it on Linux? She goes, well, here's the trick. Just take your classes, copy them into the Linux directory, and they just run as is. So full compatibility. You build your Java code, we will run it either on Windows or Linux. And I'll just show you another little interesting thing about running one of these. Let's see if I can find it here, if this works. Yes. So you see here, on my machine, I've installed what's called the extensibility package. Remember, one thing about Linux, if you've heard us talk about it, is that we treat things, in many cases, as different packages. So in order to get this to work on Linux, what you do is you install SQL Server, but if you want to run this, there's a separate package you install, like say a yum install from RHEL. And here's what you're going to love about the Linux system. It knows dependencies, right? So when I ran it, it automatically downloaded the right version of Java for me to be able to run this particular program with Launchpad. That's pretty cool, because on Windows, it's a fairly complicated set of steps, at least today there is, to go install Java, set up the path, set up all these different things, but on Linux, it's a much more smoother process. And this is the Launchpad program that runs separately on Linux. So what happens is SQL Server is able to talk to this Launchpad program. It launches your R program, your R script, your Python script, or your Java class to run outside the process space and give you that nice extensibility functionality. So that is a great compatibility story. And Nellie and I have had these conversations before. We really like to double down. Nellie, I don't know if you did your Reg Express. So Nellie, did you have your talk yesterday, or have you already had your talk with Shreya? Yeah, she's already going to talk here at the conference, so you'll be able to see this information to do regular expression parsing in a Java program. So you can see more opportunities and more examples from us, not to treat Java just as a machine learning thing, but as an extensibility to the T-SQL language. Okay, with that, let me turn it back over to Vin, and Vin, take us down the end here of talking about containers and things like Kubernetes.
Yeah, we just have a few updates here. Actually, just as a hands up, who has tried SQL Server running in containers? Wow, that's really good.
That's not bad. You were surprised by it, aren't you?
Yeah, so actually, not just, it's good that, all of you guys here are trying, but, containers is actually a journey from Microsoft as well. And one of the things that Microsoft as a whole initiative, not just the SQL Server product team is, Microsoft as a whole, we are really heavily invested in the container platform technologies. And one of the things that I have here in the first point is this Microsoft-wide container registry. Now, if you look at most of the containers today, you get it from Docker Hub. And we will still continue to publish some of our software there, but more and more over time, we're going to be publishing all of our first-party Microsoft software, and SQL Server included, a Microsoft container registry. In fact, SQL Server is already there, starting with 2019. In fact, you can only get 2019 at Microsoft Container Registry.
But Vin, I think people have asked me about that. Even when we go down that path, you still can discover it or you syndicate it, right, like on Docker?
Oh, yeah. Okay. Yeah. So this is the back end, so our registry is hosted by Microsoft. But our front end, we still realize that this doesn't have a website or user interface component to it, right? In fact, our images are still discoverable through our docs as well as Docker Hub as well. And Bob, one thing that Bob mentioned earlier in terms of, what is the most popular distribution of Linux that most of our customers are running on. He mentioned Ubuntu, mentioned Red Hat. Before 2019, all we had was our images running on Ubuntu-based containers. Now, this poses a challenge for some of our customers who wants to run their entire stack on Red Hat, and now we've made that possible. So what we have is a SQL Server image built on a Red Hat container.
And that's in their catalog too, right?
Correct.
It's on the Red Hat catalog,
Yeah.
right? Yeah.
Right, and last but not least, a big part of our team has worked on availability groups for Kubernetes, which is a container orchestrator. Now, the reason why we invest in this work is because there is no pacemaker or Windows cluster failover inside a container architecture, right? Which is why we invest in this space. Right. So just to double click on that, I'm not going to go into too much details because there are lots of slides and lots of sessions here at PASS around HA, and I'm sure everybody here is using AGs one way or another. But if you were just to put, so last year, if you were just to put a SQL Server instance in a Kubernetes cluster, what do you get out of the box? What if you didn't want to set up AG, and what do you get? So if you were to just set up so here a node is an instance, think of it as a physical machine or a VM. A pod is analogous to a container or a set of containers that's hosted within Kubernetes. So here, if you were to put SQL Server inside and says, hey, Kubernetes, I want you to start up an instance of SQL Server. You provide a definition file, and Kubernetes will place this inside a pod. And then the user would connect to a load balancing service, which exposes your SQL Server instance to the outside world or within the cluster. So this has an IP that accesses your SQL Server.
But that's like a fixed IP. So that way, right, it's a known
Correct.
IP address. It doesn't change effectively.
Correct. Yeah. Right. So what happens if SQL Server if the pod just crashed, if something happened, right? So let's say SQL Server exited. What Kubernetes does by default, if you specify, is it has a desired state, right? This is why Kubernetes is really good as an infrastructure, is because it will automatically spin up another pod. Now, what it will attempt to do, depending on the defaults, is it will typically try to spin it up on the same node, because this is much quicker. And then the load balance service is smart enough to go seek where SQL Server is running, right? However, what if the node dies? What if the whole cluster one part of the cluster just flopped over? What happens? In fact, Kubernetes knows about that as well. And then it's going to spin up, and it's going to put this SQL Server instance on another pod, right? Now, from our experience, what we've seen, even with no AG setup, the failover time, it totally varies, because if your cluster spans across a geo region, or if it's spin up within the node or across nodes, if it's between the same node, what we've seen is it's just seconds for it to spin back up. However, if your whole node has crashed, we've seen this take up to 5 minutes. right? Now, 5 minutes may not be acceptable downtime for a lot of your applications, and we totally understand that. But there's also other challenges in this architecture as well without AGs, right? You may notice that there are a lot of times where SQL Server may be in a trouble state, where it cannot accept any connections. However, Kubernetes itself doesn't have any notion, it doesn't have any smarts of what SQL Server is. All it knows is it will ask, is this process running, yes or no? So if this process is running, however, you're in a state where SQL Server is in a state where it's not functioning properly, Kubernetes will not spin up another pod with SQL Server in it, right? And so there are several challenges without having AGs in place. Which brings us to 2019 and some of the work that we've been doing here, right? What we've done is, so because Kubernetes has no notion of what a SQL Server resource or type is, that's what operators are for. So we have a SQL Server operator, and what this does is you as a user will deploy the operator, and the operator enlists a SQL Server type within the Kubernetes space, right? And on your behalf, the operator will deploy an entire AG group. And when you look at this, essentially this is AGs in a single click of a button, right? You don't have to configure this across multiple machines. What the operator will do on your behalf is start up, by default, 2 secondaries and a primary in an AG group, all load balanced by default, right? So it'll have the databases, and on top of that, you as a user, what you would do is you would put a service, and you could have, say, I want to connect to my primary, and this is your primary application. What you could also do is have another service point in the secondaries for read workloads. So this makes it really awesome for you to have your reporting applications in that space. Now, if something were to go wrong with your primary, immediately what's going to happen? The operator, without you having to automatically do a manual failover, the operator will detect that. So if SQL Server was in a problem state, it will get notified. They'll get notified by this AG agent. So notice how, like I mentioned earlier, Kubernetes doesn't have any concept of whether your SQL Server is in a terrible state or not. However, now that we have this operator there, it will be the watchdog, and it will notify your Kubernetes cluster to take the right action, right? And then the load balancer will also be smart enough to reroute to that new instance once it comes back up as a secondary. Right, so if you're interested in learning more about this and the amazing magic behind this, Surab's in the clinic today, and he is the HA expert from our team.
And Ben, I would just say we're really interested in customers to go push on this. I really, if you're interested in Kubernetes as a technology and SQL Server for high availability, starting the preview for this, starting to dig into it, starting to test and give us feedback is very important to us to make this work successfully.
Yeah. And last but not least, we've been doing demos about, one thing that Bob and I keep talking about in this session is, compatibility, choice with compatibility, right? So with that said, I'm going to just show you my last demo here.
4, I'll get you there.
Yep. Oops. There you go. So the last demo I have is just a very basic application, but it's going to use a few of the later, very flagship features of SQL Server. So here I have 2 components to my Docker Compose file. One of them is an application, and the other one's my database. With that said, we talked about Docker Compose already a lot. It just spins up multiple containers. So let's go ahead and just Docker Compose up this thing. So here I created my application. So the application container is spun up, and then I want to start up my database container. And shortly, it's going to run the schema into that container to populate it and to ensure that my application can run, right? So if I go to my browser and I go to localhost 5000, and this is where my app is running, I can see that I have this very basic product catalog application. However, if I go to here, I can see that this application uses features such as dynamic data masking. It is also using features such as row-level security, where if I switch between the user and here, I can see that a different set of rows show up, right? And this original application we built out in 2016 was built on Windows. Windows to showcase some of the 2016 features. However, what I did was, all I did was I do a backup and restore onto SQL Server on Linux, and I put into a container, and all these features continue to work as is. Here I have temporal tables where I'm querying the data at that point in time. So this is really about choice compatibility, and a big hope of mine is really to not have the session next year. As much as I love speaking.
I don't think you want to speak
and
with me again. I think it's your point, right?
Yeah.
So,
Yes.
that was great, Vin. Thank you. So hey guys, we're kind of here to the end of our session. We have one thing also after we talk about this that I want Vin to talk about. So we have a focus group for tomorrow for you to talk. Plus both of us have container sessions here at the end of the conference to talk about. So a couple things. Here's some resources. Number one, aka.ms bob.ms. I will upload this deck to the past site, but I'll also after this afternoon put this session up there so you have this deck. The other one was the SQL Server samples one you see right there. Yeah. That's Vin's replication Docker compose demos there. Next week, I'll put the DTC one right next to yours for the REPL, so you guys can start playing with Docker compose and see these scenarios. Here's other types of resources for you. Look at the fourth one down called SQL Linux Labs. So what was it, summertime we did this? Mm-hmm. We did an internal workshop for our field, and when we did it, we said, why don't we just put this on GitHub? So there is a free set of training for Linux and containers for SQL Server for you to use on that SQL Linux Lab sites. Just go download and start playing with it today. It's pretty cool
so
stuff.
if you want to get started with containers and you haven't tried it before, this is an excellent resource. And Bob and I mentioned we have 2 sessions tomorrow. Bob has a deep dive session into containers. My session is I know that many of the audience here today are admins. If you want to realize the value and some of the reasons on why containers and how you could use this on Monday morning and the benefits that you're going to have, I'm not going to teach you how to run this in production. But what I will do is show you the value of this and how you can start using it and speed things up. Because as you noticed from our demos today, we spun up containers and we tore down SQL Server just like this.
Very easily.
No installation.
So you can't do a session without making a shameless plug, right? So I went on this journey in the spring to write a book. I can't believe I did it. And miraculously, it showed up at this conference. So I am leaving actually right after this to do a book signing downstairs in the expo hall called Pro SQL Server on Linux. Lots of fun stories with our team. It's in the book as well. Hey, I wrote this book for two audiences. You're a SQL Server person, but you don't know SQL Server on Linux. Or you're actually not a SQL Server person and you know Linux. But I will tell you, I couldn't help myself. So 25 years with this team and product, I've got sprinkled throughout there all sorts of fun stories of colleagues and behind the scenes, like why did we do things about building the SQL Server product. Somebody actually told me they thought it was a decent, comprehensive book of just SQL Server itself. So take a look at that. Available on Amazon now for ebook or for print, and it is actually here at the Pass Bookstore. And if you come find me, I'll be happy to sign it because I guess that's what you're supposed to do when you write books is sign things, which is really weird for me. Hey, Vin, talk about your focus group tomorrow.
Yeah, so if you guys are interested in asking more questions about SQL Server Linux and you guys have to run to the next session after this, we do have a focus group tomorrow. So whether you want to come ask us questions, provide us feedback, or just come by and say hi, or tell us about your story with SQL Server Linux and the general direction of your company, feel free to swing by 11 to 12 tomorrow.
Awesome. So we're going to include the talk now, but we're going to stay here for the next 8 minutes. We have 8 minutes left in this session to answer your questions. We don't have like a mic, so you're going to have to kind of come up and yell loud to us. But if you need to leave, we totally understand that. But Vin and I'll stay here for certainly the next 8 to 10 minutes to answer your questions. Thank you so much.